Whoa, that's cool. It's actually streaming live now. Hey, cool. That works out nicely. Awesome. Let's see. Ah, there we go. Hello. Whoa. Hello, hello. It's actually streaming live now. All right. Hey, cool. That's works. Let's see. We are looking for. Let's see. Physics 12, term 1 there review. We go. Hello? Hey, can you hear me okay, Connor? Hello? It's actually streaming live now. Alright, hey, cool. That's right. Let's see. We are looking for. Let's see. Physics 12, term 1 there review. Go. Hello? Hey, can you hear me okay, Connor? Hello? Find that file now. Alright, hey, cool. That's right. Let's see. There we go. We are looking for. Can you hear me okay? Physics 12, term 1 there we go. Hello? Hey, can you hear me okay, Connor? Hello? Find that file now. Alright, hey, cool. That's right. Let's see. There we go. We are looking for. Can you hear me okay? Physics 12. Okay. All right. Yeah, I heard that too. I heard that too. Okay. The two audios still coming through. Okay. Yes, only one audio this time. All right, good. Okay. So I think you guys went through the multiple choice already. But quick overview. My pen. I don't have my pen with me. That sucks. There we go. All right, there's my pen. Can I draw? Cool. Okay. All right. So I guess we'll go over the multiple choice quickly before we dive into the written section. Just to remind you guys of the correct answers. So for the first one, let's see if I can zoom this in a bit. There we go. Whoops. Yeah. All right, there you go. Okay. There you go. All right. So this is the one I gave you guys today. I think most of you guys got it. If you did not get it, then you can probably just follow along and I guess think about it. If you guys have any questions, feel free to ask them in chat. There is going to be a slight delay, so if I don't quite get it, or I guess I don't quite answer it right away, that's why there's a slight delay. All right. So number one. Best answer for this one, which of the following contains two vectors? That would be C. This one contains velocity and displacement are both vectors. 2. Box moving across the floor with a constant acceleration of A. Force on the object at any point is F and velocity is V. Wait, is this the right one? Which of the following is equal to the mass of the box? Let's actually check if this is the right one. Oh yeah, that is the right one. It's the right one. It's got this question on there. All right. All right. 2. following equal to mass of the box? This was a straight application of Newton's second law, F equals ma. So just rearrange it for mass. So that would be this one. Okay. 3, which of the following is not part of Newton's laws of motions? Objects stay in motion until an object Yes, object stays in motion until outside force acts on it. That one is sort of true. B, object exerts a force, another object feels twice the amount of force. That one is not true. It feels the exact same amount of force. And object's acceleration is directly proportional to the force acting on the object. So C and A are both true. So B is the only one that is not true. Variation of this would be if I just said this was restated as Newton's third law, so like the object exerts a force on another object, feels the exact same force. That'd be a variation of that question. 4, in order to have less power, you want to increase the amount of time it takes to do the same amount of work. B and C will both increase your power because remember reminder that power is work over time. So to increase power, you either increase work or you decrease time. All right, number 5. This one, circular path. This requires you to sort of identify how force and velocity are related to each other. So force is proportional to velocity squared. So if I quadruple the force, I need to double the velocity to make that up. So that would be A, double velocity. All right, number 6. Objects in uniform circular motion. What can we say of the magnitude? Okay, so only magnitude, not direction, just magnitude. Everything is constant. All the magnitudes are constant. So it would be V, A, and F. The only thing that is not constant would be the direction. So direction is not constant. Direction is not constant. Although if you ask Mr. Peterson, he would argue that the direction of A and F are constant on a radial, I don't know. In a circular frame of reference, the acceleration and centripetal force would be constant in direction. Okay, force of an object in uniform circular motion. Force is always parallel to the acceleration. So your objects will always accelerate in the same direction as your force. In all cases, not just for circular motion, because, again, F net is mass times acceleration. So F net and acceleration have to be in the same direction, always. Just so happens that in circular motion, it's just circular. Don't ignore Mr. Peterson, he's great. All right, number 8. Which of the following is another name for gravitational field strength? I should make note that Ishan messed up his formula sheet. So if you guys did not hear me in class today, and if Ishan, if you are watching this, you need to fix it. You have your formula for gravitational field strength as this. So you had it like written like this, and that's all. This is not gravitational field strength. This is gravitational force or force due to gravity. So Ishan had his formula sheet written like this. This is not right. This is not right. Okay, this is not gravitational field strength. This is gravitational force. Okay. Gravitational field strength is, if you want to write the actual formula for gravitational field strength is this. Yeah, there we go. Gravitational field strength. So gravitational field strength is just G, which is just big G times big M divided by R squared. Okay, that's gravitational field strength. So this is also because we know g is just acceleration due to gravity, so that's just a. That's just a. All right, number 9. Projectile is launched at some angle with some velocity. What is true about the vertical velocity of the projectile? Ignoring effective air friction, experiences acceleration equal to g. Okay, the other ones are. Let's see. The other ones are not true. This is actually this would be minimum y value at the peak of its flight. And not the vertical velocity, but the horizontal velocity remains constant. So remember that. Again, these are just variations of the questions that may show up. If Ishan did that on purpose, he might have read the one comic from physics, or he might remember the one comic from Physics 11, where all the answers are wrong. All right, number 10, we discussed this in class. This is not supposed to be the cart. This is supposed to be the direction. In which direction does the force of friction act in? Okay. Otherwise, if the system remains motionless, the cart's not moving. There we go. So here you have to determine force of gravity pulling down that way, determine the sliding force down this way, and then whichever force is bigger will cause the actual motion, and friction will oppose that. I actually don't remember, so let me pull out the calculator. So force, that one's easy, 2 times 9.8. So this one is 19.6. And then the sliding force would be 3.6 times 9.8 times sine 26. So sliding force was 15.5 newtons. So gravity will pull down. So the cart will actually move this way. And yeah, so Connor, you are correct. Friction will act in the D direction. There we go. All right. So that's all the multiple choice we did in class. Most of you guys got that, so that's good. On to the written questions. So in this version of my term exam was weighted more towards the written portion. There were only 10 multiple choice, and each multiple choice was 1. Wait, what? Oh, well, that's good to know. That's good to know. Oh. All right. Okay, so mass is suspended below, determine the mass of the object. So this requires us to remember, I should have labeled this a little better. The tension is going this way in the string. So based on vector components, this portion of the string will be 100 newtons. This 57-degree Kent. Hi. Glad that you got some use out of my classes. It's good to know. I hope your sister's doing well. All right, so that's 57 degrees. Using parallel angles, this would be like a Z rule. I know math teachers hate it when we call it Z rule, but whatever. Okay, so that's 57 degrees there. We can use that to figure out this y component. This y component is the sine portion of this triangle. So this would be, wait, I don't want to use sine. I want to use tangent. There we go. So I can use tangent to figure that out. Opposite over adjacent. So y is 100 times tan 57. Let's pull that up. So 100 times tangent 57. So that's 154. Let's go over to 154 newtons. There we go. And then that's the upward force, which matches the downward force, which, if you want to find the mass, this is the equivalent to the force of gravity. So we'll just divide this by 9.8. So mass will be 154 divided by 9.8, which is approximately 15 kilograms. Okay, give or take, I think. There we go. That's 15 kilograms. Variations of this problem would basically be find the tension. I think I asked this on a test earlier. Was find the tension, and I would give you the mass, so you find the tension. But there you go. All right. 12. Cannonball launched with an initial velocity of 28 meters per second at 40 degrees above the ground. How long does it take to reach maximum height above the ground? So you'd be flying this way. So 28 meters per second, 40 degrees. There we go. Maximum height. Cohen actually solved this earlier, and he noted that maximum height, you have 0 y velocity at maximum height. So we'll find our y velocity. There we go. Here I can use sine, so this will just end up being, shoot, what am I doing? Y equals 28 times sine 40, like that. So my y component ends up being 28 times sine 40. So I have about 18 meters per second going up. 18 meters per second going up. And then I can use, let's see, I have my initial y velocity. So that's my initial y velocity, final y velocity. I need, oh, I have an acceleration. Can't forget that. So that is my acceleration. And we're looking for time, so I can use this equation. V final equals V initial plus AT. V final is 0. V initial is 18 meters per second. Acceleration is negative 9.8 times t. So t becomes 18, or negative 18 divided by negative 9.8. That equals t. So that is approximately 1.8 seconds. Approximately 1.8 seconds. There we go. All right, that's number 12. Now, oh, I see we now have an extra person watching. If any of you guys do come in late, you guys should be able to rewind the video and watch what questions you did miss. Okay. All right, there you go. That's number 12. 13. I know some of you guys were mentioning earlier in class, is it really that simple? And yes, it is, if you know what you're doing. And you guys should always think that way. If a question is as easy as it looks, it's probably because you know what you're doing. Okay? That's how you should think about those things. So here we have a 3 kilogram, here's a boulder. Boulder, 3 kilogram rock flying towards the boulder. 3 kilogram rock. It has a momentum of 24 kilogram meters per second. This rock has 0 momentum. After they collide, the small rock's momentum changes to 12 kilogram meters per second, and the large boulder gains some momentum this way. Okay. Now, because of conservation of momentum, my total momentum has to remain the same. Hi Colson, glad you could make it. So there's my total momentum is 24 kilogram meters per second. That doesn't change. So here, my total momentum is still 24 kilogram meters per second. So what's missing? 12 kilogram meters per second. So therefore, I should actually really label this as like P1 and P2 and P1 and P2. Therefore, because my total momentum has to remain the same, which I should say is a sum of P1 and P2. So this is going to be P1 plus P2. So therefore, simple addition, P2 should equal 12 kilogram meters per second. So there we go. So just remember, conservation of momentum. I would like, if you do get a question that seems this simple, to lay out your thought process similar to what I've done here. So here's the first part. There's the first part. And then you can clearly see conservation of or total momentum here. And then the second part, like this, there's a second part. And again, clearly see total momentum remains the same because of conservation. Okay. If all you put down is 12 kilogram meters per second north, it's not that informative. So I would like it to be more informative. Okay. Get into the habit of that if you haven't already gotten into that. All right. On to the next one. So 4 kilogram block sliding down a frictionless inclined plane as shown below. What is the block's acceleration? The only force acting on this block would be the sliding force as follows. F slide. Because it's frictionless, there's no friction force involved. So this also happens to be my net force. And we have formulas for both of these. So if you don't remember the formula for F slide, this was Fg sine theta, and F net is just mass times acceleration, like that. Okay. Fg ends up being mass times gravity times sine theta. Ma is mass times acceleration. So it turns out that since this is frictionless, the mass of the block doesn't actually matter, surprisingly. So the acceleration just ends up being g times sine 34. So acceleration is going to equal, see, g is 9.8, unless we're really far from the Earth, times 34 sine. So A is about 5.5 meters per, 5.48, I guess, 5.5 with proper significant figures, which I really should pay more attention to. There you go. All right. That's the block's acceleration. Okay. Yeah, so make sure you guys have this formula down. The F slide and F compress formulas. Make sure you guys have that down on your formula sheet. And if Ishan did not put it on his formula sheet, you guys should think about making your own. All right. This question is very similar to the previous one. I think question 11? Yeah, very similar to question 11. It's actually the variation of question 11. So here, we want to find the tension. So we want to find this portion. We work backwards. So we know we have a force of gravity here, which is a mass times g. So this is going to be 55 times 9.8, which is go into engineering, Connor. They only care about 3 significant figures, according to my engineer friend. Alright, so this is 539 newtons. There we go. 539 newtons. So that's the downward force, which this has to match. Otherwise, this string won't be able to keep it up. So 539 newtons there. Okay. Based on static equilibrium, the x component has to match the tension, so we just have to find the x component of this triangle. This is 35 because of Z rule again. So we can use tangent. So tangent 35 equals opposite, which is our 539 newtons, over adjacent, which is our x component. So x becomes 539 newtons divided by tan 35. Okay, and I don't want to divide this. 539 divided by 35 tan, 769.8. Wait, is that right? Yeah, that's right. 769.8 newtons. Now, it looks really strange because my diagram is drawn so poorly. In actuality, this tension line here should really be more like this. this. Yeah, it should really be more like that. So if you're wondering why this number seems really, really off, it's because the diagram is really bad. And I should really take better care in how I draw some of my things. Anyways, there we go. All right, so that was number 15. So I think so far these questions might be relatively straightforward. I think George was mentioning it in class that this exam seemed easier compared to the other one that you guys had last week. At least the example last week. All right, and here's 16. This one, for whatever reason, torque questions always seem to throw everybody off. But especially a question like this, because we're missing a fair amount of information. Like, we have the horizontal beam. We'll assume this is a uniform horizontal beam to make our life easier. If the beam is balanced, calculate the forces that each support exerts on the beam. And that's important to know, because if it's balanced, that means that the sum of all my torques is 0, and the sum of all my forces is equal to 0. And we'll be using both, okay? Now in class, I mentioned for a problem like this, because we don't know any information about A or B, we pick our pivot at one of those points. So I will pick my pivot here at A to begin with. I'll put in some numbers. So this is 1.5 meters. This is 2.0 meters. The entire beam is 6 meters. So after some simple math, this should be 2.5 meters there. And somewhere in the middle here, there's my center of gravity, which is, I think, 1.5 meters from the pivot that I've chosen. There we go. All right, so they're all labeled. Let's see. Okay, so we want to calculate, we want to balance out our torques and then balance out our forces. So looking at this diagram, we know support B is going to exert a force going up this way. We'll call that force B. We don't know what that is, but that's okay because we know the center of gravity exerts a force of gravity equal to 10 times 9.8. So this will be 98 newtons. And then the torque due to the center of gravity will be 98 newtons times 1.5, which is, I can't do that, 98 times 1.5, 147 Newton meters of torque. Now, the torque due to B must match that, but going in the opposite direction. And since we know, we don't actually know what force B exerts, but we know how far force B is from pivot A, which is 2.5 meters. So 147 Newton meters. So force B has to exert a force of 147 divided by 2.5, 58.8 newtons. There we go. All right. So now we know how much force B exerts. And then to find force A, well, we just abuse this fact where the force is equal to 0. So force A exerts upward, center of gravity exerts downward, force B exerts upwards. So force A, I'll call it force A minus the force of gravity because it's going down, plus the 58.8 newtons of force B going up. Force A has to equal 39. No, wait, I'll just calculate that. 98 minus 58.8. 39.2. Yay, 39.2. 39.2 newtons. That has to be force A. There we go. Now, if you chose point B as your pivot, so if your pivot, if you choose this as your pivot, you should still come out with the same result. I think I overheard Connor. He used point B as his pivot, and he got 39.2 for force A, and then again using this information is able to calculate force B as 58.8. So it doesn't matter which pivot you choose. You can either choose A or B. Just don't use the center of gravity because then you end up having two unknown forces, which is not ideal because it's hard to solve two unknown forces with one equation. All right. Okay. So that one was not as straightforward as the previous ones. Okay. So be mindful of that. All right, scrolling down onto this one. This one is a straight kinematics problem. I think one of your one of your two tests, this was a question on one of them, but the numbers were slightly different. Alright, so also I think this one is a lot more free form because it just asks you straight up, determine time of flight and determine height of cliff. Okay, so time of flight, good thing we know that we have a 200-meter or 250-meter horizontal flight. So we'll use that information. So I'll go A part. So 250-meter, we can just use this information where distance equals velocity times time. But we're going to be operating in the horizontal direction. So we have to do a little bit of prep work prior to starting this out. And that prep work basically requires us to calculate the x component and the y component. So x component, the velocity in the x direction will just be 20 times cosine 35. And the velocity in the y direction, that looks like a square root sign. Oops. Totally messed that up, sorry. There we go. Velocity in the y direction. There we go. There, better. Okay, velocity in the y direction will be 20 sine 35. All right. Okay. So calculate those out. 20 times cos 35 ends up being 16.4. We'll go 16.4. And then velocity in the y direction will be 20 times sine 35, which is 11.5. Okay. So calculating our time using our horizontal velocities, we have a horizontal distance of 250 meters. Vertical velocity, no, not vertical. Horizontal velocity is 16.4 meters per second. Time is unknown. Total time of flight ends up being 250 divided by 16.4. 15.2 seconds. 15.2 seconds. So there's our time of flight. There's our time of flight. All right. Now, for the height of the cliff, we just need a time of flight, and we can use this equation for the height of the cliff. Distance in the y direction is the initial velocity in the y direction times time plus 1/2 a in the y direction and then time. Acceleration in the y direction, it's falling or it's fighting against gravity, so this will be negative 9.8 meters per second squared. Then we just fill in some values. So we don't know what dy is. We do know what the initial y velocity is. That's 11.5 meters per second. Time is 15.2 seconds. 1/2. Acceleration is negative 9.8. If you put positive 9.8, then your object will have a much larger displacement in the y direction. Oh, I almost forgot. This should be t squared. And then 15.2 squared. So, plugging all that into our calculator. So, 11.5 times 15.2 plus 1/2 times negative, whoops, yeah, 1/2 times 9.8, make it negative, times 15.2 times 15.2, because I don't, there's a square button, there you go. So the, wow, that's a really tall cliff. Negative 957 meters. That is how tall the cliff is. Some of you might be wondering, why do we have a negative distance? Because we started up here and we fell. That's why. That's all. So the negative distance should make sense because, again, we're falling. We're falling. You can report it either as a negative height or a positive height. It doesn't matter. Given the context of how we solved for this, the negative distance makes sense. All right. So that was 17. On to 18. All right, so here we have two objects connected as shown below. Mass is 20 kilograms. Determine the... Oh, I only did that twice, Connor. Yes, here. I did that twice. Because it's 15.2 squared, so I just did 15.2 times 15.2 because I did not realize I have a square button over here. I could have used the square button, but I didn't see it at first. And the other 15.2 is here because that's this part of the equation. Okay. Hopefully that makes sense. All right. Okay, on to 18. Two objects connected below. If this is 20 kilograms, we want to determine the acceleration of the system and the tension in the string. Okay. Oh, it's frictionless. Yay. Okay, it's frictionless. Frictionless. Yay. Maybe I'll make this problem harder by making it non-frictionless. That'll be interesting. Anyways, for this question, we'll determine the acceleration of the system and the tension in the string. So to determine the acceleration of the system, we need to know how much net force is present. And then we can use the net force equation to figure out the acceleration of the system. So the net force on the system is easy, because the only thing pulling on this system is the gravity due to the 25 kilogram mass. So this will be 25 times 9.8. So this is 249, I think. Oh, 245. Okay, 245. So this will be 245 newtons. So that's my net force. So I can say, okay, if my net force is 245 newtons, then the mass of the system will be the 20 plus 25, and I can figure out my acceleration. So my acceleration will be 245 divided by 45, which is about 5, I think. Yeah, 5.4. Hey, it's the second time this acceleration has popped up. There we go. So there's the acceleration of the system. Okay. Now, a variation of this would be if the surface was not frictionless. If the surface was not frictionless, then you'd have to take into account that there will be some force of friction, which would be equal to mu times Fn. But then the Fn would come from this relationship here. So the force of friction would be mu times mg of whatever this block is. Okay, that's if we had friction. And that would just change your net force equation from being just gravity. Your net force would then be the force of gravity minus the force of friction. But then the rest of it's exactly the same. All right. I will go back to the original problem. All right, back to the original problem. So we found the acceleration of the system. Now we want to find the tension. So the tension, we will take, I can change colors. Analyze one of the blocks. So I'm going to pick this block because that's the easier block to analyze, because there's only one force acting on this block, which is, luckily enough for us, tension. All right, so analyzing this block, we know that for this block, F net is still equal to mass times acceleration, but the only force acting on this block is tension. So this is tension. Tension equals mass of the block times its acceleration, which happens to be this number here. So 20 times 5.4, so it's going to be 100 and something. 20 times 5.4, 108. So there we go, 108 newtons. Why did the 19 pop up? Okay, there we go, so that's 108 newtons. Now, if you want to be super accurate or super correct, and you want to check all your work, we need to figure out how much tension is here also. Okay, now if everything works out well, these tension forces should cancel. They should be the same, so this tension and this tension should be the same, because it's the same string, and because of Newton's third law, both masses should exert the same force on each other. So this tension here should be the same as this tension over here. Okay? Now to work with this block, let's change the color. I don't know, purple. These are different colors I normally use. So we'll analyze this block, and on this block, the forces in question, you can still say the following: F net is still mass times acceleration, but the F net is going to be a combination of Ft, the tension, and then gravity. And you can say, okay, well, I know the gravity is doing most of the pushing, so I can say gravity is bigger. I'm going to subtract tension from it, and that will equal mass times acceleration. Now, the danger with using M2 is a lot of people will forget that this should only be M2 and not the combined mass. So we'll write the following: M2 times 9.8. Actually, I know what M2 is. Why am I doing this? I can just replace M2 with its mass. So this is 25 kilograms. Okay, minus force of tension equals 25 kilograms times 5.4. So this ends up being, after some algebraic rearrangement, you get 25 times 9.8 minus 25 times 5.4 equals force of tension, which, if you do this, it should come out to about 108. Let's do it. Blocking equation. So 25 times 9.8 minus 25 times 5.4. Oh, it's actually slightly higher. That's odd. Newtons. There we go. Did I mess up in my previous one? Oh, I might have, because I only used 5.4. I should have used 5.44 in my original one. So if I recalculate that, so let's recalculate the other one, because they should be the same. So if I used 20 times 5.444, whatever, yeah, 20 times 5.4444444. I still get about 109. 109. Okay, and then if I repeat the calculation down here with 5.4 repeating, 25 times 9.8 minus 25 times 5.4 repeating. There you go, that's better. Much better. Okay, because they should be the same. They should be the same. Yeah. 109. Haha, there we go. Alright, my mistake, I rounded off way too soon. Should have kept more significant figures in this calculation when I carried over into the other calculations. Alright, but yeah, they should be the same. Regardless of which block you analyze, they should be the same tension force. Which makes sense, because when you analyze the system, the tension forces didn't exist, right? Our net force here, this net force here was just the force of gravity. Okay. All right. So that's that. I think this question was very similar to one of those questions you did on the review, the Halloween review. Alright, I think there's 2 more questions left. Ah, the raptor question. Oh, and the comic. We'll skip the comic. Maybe not. Okay, amusement park ride. So this one, we just want to determine the force that the seat exerts on the rider at the top and at the bottom. You won't be able to get an actual number for this. Your final answer will be in the form of normal force equals mass times something stuff. Okay, so it'll be something like that. Pink, sure, why not? All right, so at the top, it helps if you look at, or if you, break it up into the top and then draw your diagram. There's the seat, and the seat will be exerting a force this way, but you're sitting here, you will feel gravity pulling you down, and then you've got overall some kind of centripetal force pulling you down this way. Okay, so centripetal force, in this case, will be caused by gravity. So centripetal force will be caused by gravity, but gravity is working against the normal force at the top, like that. So you can write the following. Am I given speed? No, I'm giving periods. I have to use the more clunky version of FC, which will be mass times 4 pi squared r over t squared equals force of gravity, which is mass times g, and then normal force, like that. Although I should have rearranged to solve for normal force, to isolate normal force. I'll do that now. So I will add normal force and subtract that. So normal force ends up being mg minus m 4 pi squared r over t squared. Notice that I've got m's in both terms. So I've got an m there and m there. I can factor the m out, so I get the following. G minus 4 pi squared r over t squared. And then you should be able to enter all of these values into your calculator. So all of this should be able to go into your calculator, and you'll get m times some number. So let's write it out. So it's 9.8 minus 4 pi squared. The radius is 15 meters. Oops, this would be pi. And then we have a period of 25 seconds. That's actually pretty long. That's pi squared. It's actually a pretty long ride. Depends how often you go around it, I guess. Alright, so the number 9.8 minus 4 minus, I have a pi button. Yay, I do. Pi squared. Oh god. Alright, where am I? Whoops, I think I messed up. Okay, let's clear that. 9.8 minus 4 times pi squared times 15 divided by 25 squared. I'm not sure if this calculator will... Okay, good, okay. Okay, and we get a number 8.85. So normal force will end up being whatever the mass of the person is times 8.85. Okay. Yeah, 8.85. There we go. And I guess that has the units. It'll have really awkward units. Yeah, I'll leave it at that. Actually, this will be in meters per second. This will be in meters per second. Yeah, that'll be in meters per second. Or sorry, meters per second squared. There you go. So this is at the bottom. At the bottom. This would be the normal force of the person at the bottom. So if you are more massive, you will actually experience more normal force on the seat. Or you'll experience this kind of normal force at the top. Okay, at the bottom, do the same kind of analysis at the bottom. So at the bottom, let's do this in blue. So at the bottom, draw my diagram there. where's my seat? Our normal force is going up this way. We still, scroll down a bit. We still have gravity going down this way, and centripetal force is going this way. Now, in this case, the normal force has to be bigger than the gravitational force, because normal force is providing the centripetal force in this case. And if I rearrange this, normal force ends up being centripetal force plus force of gravity. Now, the great thing about this is we've already done this effectively, because if you look up here at this equation here, we had Fc equals Fg minus Fn. Here we have Fc plus Fg. Wait, yeah, here. I'm actually looking at this one here. Yeah, there we go. So this is Fg minus Fn, or Fg minus Fc. What am I talking about? This is Fg. So this is Fg minus, and this one here is Fc. Okay, so this is Fg minus Fc. At the bottom, it's Fc, or basically Fg plus Fc. So we can write down the equations, but I'm going to pull the mass out right away. No, I will not pull the mass out right away. I will write it out and do it step by step. So hopefully I don't lose anyone. Plus mass times gravity. There we go. And then we can pull out the mass like we did last time. So they both have masses. Then this becomes 4 pi squared r over t squared plus g. There we go. Then do the same thing we did as the last one. We just figure out what this number is, which is disgusting. I can't. Can I change this equation? I want to change this equation, but I don't know how. Okay, whatever. We'll do it. So 4. Oh, geez, clear everything. So 4 times pi squared times 15 for the radius divided by 25 squared for the time. But this time we're adding the 9.8. So this becomes m times 10.7 meters per second squared. There you go. And that is the normal force at the bottom. At the bottom. Okay. So notice again, we don't actually have a number. We just have mass times some number. Okay. Now both of these answers kind of make sense because you should feel more normal force from the seat at the bottom of the ride than you do at the top of the ride. Okay. Due to what's causing the centripetal force at each case along the ride. Okay. All right. Okay. I think that brings us now to the very last question. This is the Velociraptor problem. This is actually exactly the same as the... Oh, wait, no, this is not the same as the one on last week's. This problem is actually slightly different because these raptors are more evolved and can accelerate infinitely. So they don't have a top speed, they just accelerate and accelerate and accelerate until they catch you and eat you. So this problem is actually, in some ways, easier than the previous one, if you can believe it. Okay, so when it spots you, you begin to flee at 6 meters per second. This is interesting because if you can run faster than that, feel free to use whatever your sprinting speed happens to be. Okay, provided we'll assume your adrenaline is enough. If you can run like Usain Bolt, why are you at NVSS? You should be trying out for the Canadian track and field team. All right, so here we go. Now, the thing with this is very similar to the previous problem, is that the raptor catches you when the distance it has run is equal to the distance you've run plus your 40-meter head start. Okay? Now, the distance you run, this is easy, because the distance you run is whatever speed you run at, times the time it takes to run, or your living time, I guess, plus 40. And the raptor, because it has it can accelerate infinitely, we will use this equation, VIT plus 1/2 AT squared. Okay. Because the raptor has, we'll assume it's starting from rest, so we don't have to worry about that term. So this just becomes 1/2 times AT squared equals whatever velocity you run times T plus 40 meters. So putting in some numbers, this becomes 1/2 times 1, because the raptor is accelerating at 1 meter per second squared, T squared. We'll assume you have a standard speed of 6 meters per second, and then 40. Now, same rule applies. You have to use quadratic equations to solve this, because I do not think this will factor nicely. Because when we figure things out, or when we move things over like this, I want minus 40. I guess I could actually show you how to solve this using Desmos. Yeah, so there you go. So once you solve it, or once you rearrange it to look like a quadratic, there you go. At this point, you can use quadratic equations. So use quadratic equation techniques. Quadratic equation techniques. Either solve it with the quadratic equation. You could solve it by graphing. If by some miracle this factors, you could solve it by factoring, but I don't think it factors. So I will solve it by my preferred method. I will graph it, because it's so much easier to graph a question like this. I know some math teachers really don't like students graphing, but you have a graphing calculator. Why not use it? Alright, so here's Desmos. If you guys don't have Desmos, I highly suggest you get it. I don't use GeoGebra. I like Desmos. It's way easier to use. So here's the equation in question. Minus 6x. I'm just replacing the... What am I replacing? I'm replacing the t with x's, because Desmos doesn't allow me to do that. Anyways, so according to this, the raptor will catch you at 2 points. There are 2 possible answers where the raptor catches you. So t will either equal negative 4.77 seconds, okay, or it'll equal 16.77 seconds. Okay. So I think we what did we decide? We decided last time we did this problem, or with last week's raptor problem, we decided the raptor can somehow catch you before it spots you due to your infinite acceleration from 0 to 6 meters per second. Or whatever your speed is, because I don't give you guys an acceleration. So you just because you immediately accelerate to this speed here, you have an infinitely large acceleration which sends you back in time, and the raptor catches you. Or you can just ignore time travel, and then we just accept this answer here. So you have 16.7 seconds to live before the raptor catches you. Okay. There we go. All right, and that does it for this one. So this version of the exam, there's a lot more written, way less multiple choice. Oh, complete the comic. I will just say the following. There we go. There. Ta-da. All right. This should be available. Oh wow, it took a while. But yeah, you guys can, if there's any particular question here that you're not sure of, feel free to rewatch the video or come find me tomorrow during some time in the morning. Your exam will be similar to either this one or the one I gave you last week. I think the majority of you guys wanted a slightly heavier weighting towards the multiple choice. So I will either give you... No, I don't think I'll give you more questions. I'll just weight the questions as 2 marks each for the multiple choice. And then the written questions will make up the remaining 20 marks. I haven't quite decided on a theme yet for the written questions, but I think I might stick with Raptors, because that's what I've used traditionally in previous years. I don't feel like breaking with tradition today. All right, if you guys have any questions, again, come find me tomorrow morning. I should hopefully be in class earlier than usual. If not, you guys can bug me during block 2. My other physics class is just reviewing anyways. All right. Have a good night, everybody, and I will see you in the morning.